Before actually seeing the code, let's see how we convert a decimal number into binary number. Let's take an example of 124.34. The integer and the fractional part will be converted separately. So let's first see how we convert the integer part. Since binary number is a base to number system, we have to divide the number by 2, write the quotient below it and the remainder next to it. And we have to repeat this process until we get 0 in the quotient. The remainders obtained are the bits of our binary number. The remainder at the bottom is our MSB, the most significant bit, and the remainder at the top is our least significant bit.
Now let's see the fractional part, how we convert it into binary number. We multiply the fraction by 2. Why 2? Because binary is a base 2 number system. Whatever product we get, we separate out integer value from it. Then with the fraction, we repeat the same process of multiplying by 2, and we continue doing it until we just get an integer value as the product. I'm stopping here because it will be non-terminating. So 0.34 can be represented as 0.01010 in binary number system. So 124.34 can be written as 111.100.010 in binary number system. Now let's see the code. Now let's declare a variable decinum of type float in which we'll input a decimal number from the user. Now let's create a function decinum which will convert our decimal number into binary number. The function will have a string written type and will take a float number as a parameter. Now we want to separate out the integer and the fraction part from our decinum. We can do this by storing the value of decinum to a variable int part which is of type int. The compiler will convert the decinum which is of type float into int type, and the int part variable will contain the integer part of the value stored in decinum. This is called casting. Now we got the integer part. We can get the fractional part by subtracting decinum by the int part variable in which we are storing the integer part of decinum and storing the value in another variable of type float which is called float part. Now we have the int part and the frac part separated out. We'll first convert the int part into binary number. Now let's see. Let's create a while loop which will run until int part is not equal to 0. We'll need an array of type int for storing our remainders, as we saw in the previous example that remainders are the bit of our binary number. So rem index I equals to int part modulus 2 means whatever remainder we get when we divide int part by 2 will be stored in rem index I. So let's declare a variable I and initialize it with 0. After that, we'll divide int part by 2 and store the value in the int part variable itself. So int part slash equals to 2 just means int part equals to int divided by 2. After that, we'll increment I by 1. I plus plus means I equals to I plus 1. Now we have the remainders stored in our rem array. We'll now use a for loop to concatenate all these remainders into a string to represent our binary number. Since the remainder at the last index is our MSB, the most significant bit, and the remainder at the 0th index is our LSB, we'll need to run the for loop backwardly, that is from j equals to I minus 1 to j is greater than equal to 0. Why I minus 1? Because I gives us the length of the rem variable, and if we have an array of length 5, the last index will be 5 minus 1, that is 4. Now let's create a string variable which will be just empty, and we'll concatenate rem index j to our string variable binary num. Concatenation means appending to the string, and we do it using the add operator. But there's a problem. The value stored in rem index j is of int type, and let's say if it has the value of 0, the compiler will convert 0 to the character whose ASCII value is 0, and our string variable binary num will have some different values stored in it. So we add 48 to it. So if rem index j is 0, it becomes 48, and if it's 1, it becomes 49, and so on. So when the compiler convert the int type to character type, the binary num will store the numeric characters.
Now we'll create a while loop which will have the condition true always. Inside the while loop, we'll multiply frac path by 2 and we'll store the result in the frac path itself. Now we need to separate out the integer and the fractional part from the number stored in frac path variable. And we'll do it by storing the value of frac path to int part variable. So int part now stores the integer part of the number stored in frac path. And then we'll subtract int from frac path and store the result in the frac part variable. So frac part now have the fractional part. We'll put a condition that if frac part equals to 0.0, we'll break the loop. We'll concatenate int part to binary num, and don't forget to add 48. Now we'll simply return binary num from our function, and in the main function, we'll print the return value of the function. Now let's run the code. Let's input the value 124.34. We got our answer. So that's it. Thanks for watching.